In this section, we plan on using this one formula and using it for all its power. Here, you might recall some of the letters. They're the same letters that we used before. A is the account value. PMT is the amount of payment. Now, this is what's called a savings plan. That means you're going to deposit the same payment amount periodically. Probably every time you have a compounding, you'll make a payment. So you deposit a certain amount called PMT in, and then you do all this stuff to it, all these computations, and that tells you how much you'll have in the future. So this is, I call it a periodic savings formula, because you're putting in periodic payments that we call PMT. And you'll do that at the same time, maybe once a month, maybe every time you're paid or something like that. In any event, we're going to use this formula several times and hopefully you'll be comfortable with its use. I'm going to write down how you can get it to be done on the calculator in one line also. So it's a difficult formula, believe me. You're going to want practice with it. Our first example, we have a savings plan for 15 months and an APR of 5% and monthly payments. So let's go ahead and put these information down here. The APR, we're going to need that. 15 months. That's going to be our N. Well, actually, no. It's not going to be our N. N is going to equal 12 because we're doing monthly payments. Okay, the PMT, that's going to equal 250. APR, that's 0.05. And how long is 15 months? Well, in terms of years, 15 months is 1 year and 3 months. So 15 months, if I multiply by 1 year divided by 12 months, these months will cancel out, and it looks like I'm going to have 1.25 years. So I can plug all that stuff in. Let me go ahead and write the formula out. It's PMT, then we have a bracket, which you can use regular parentheses for that. So is APR over N, and that's to the N times Y minus 1. Finish the bracket, and all of that is over APR divided by N. Now, I'm going to do this on the calculator in the following format. So I'm going to have my PMT will come first, then I'll have a dot or a multiplication sign. Now my calculator doesn't have brackets, so I'm just going to use parentheses. Now, depending on how your exponent works, my calculator, the exponent will actually go up there. But if not, if you have to use like a caret symbol or something like that to get an exponent, you'll want to put these numbers in parentheses. Finish off this parenthesis, and then slash. This part needs to be in parentheses, this APR slash N. So let me go ahead and plug in all of our numbers here. So my payment was 250. 1 plus the APR is 0.05 divided by 12. And then in the numerator, in the exponent here, I have 12 times 1.25. And then subtract 1, slash, and down here I'll do 0.05 slash 12. We'll see how hard this is to get into the calculator. All right, I've positioned my calculator right underneath of this thing. Let's see if I can get it to go in. 250. Then I'm going to start a parenthesis and then a second parenthesis. And then I'm going to do 1 plus 0.05 divided by 12. And let me finish that parenthesis. Now then I'm going to take that to an exponent. Now 12 times 1.25 is 15. And then I minus 1. I finish my parenthesis. And now I'll divide by the bottom stuff. So I'm going to divide 0.05 divided by 12. And enter. Let's see what we have here. It looks like 3861.37. Our next example here is an IRA account. Here, this person is going to put $100 into the account each month for the rest of their working years. So we're looking at, they started at age 22 and they're going to age 65. So the number of years is going to be 65 minus 22. So that will be 43. Now, since the payments are put in monthly, we're going to have the number of compoundings be 12. The APR of 8%, that's 0.08. And what else do we need? Well, let's write the formula and see. That's how much I want to have at the end. So we have PMT bracket 1 plus APR over N to the N times Y minus 1 divided by APR divided by N. All right, let me plug this stuff in. So our payment then is how much? $100 is how much he's putting in each time. So I have 100. I'll do double parenthesis. 1 plus, now the APR was 0.08 divided by 12. Raise that to the 12 times 43 power. And then I'll have my APR 0.08 divided by 12 again. So take a look at that. Make sure that if you're working on this with me on the computer, make sure that you take a good look at that and have everything in the correct place. This up here, this 12 times 43, I'm going to do separately. 12 times 43, that's 516. And now let's have the calculator do it. 100, double parenthesis, 1 plus 0.08 divided by 12, finish that parenthesis, raise it to the 516th power, then subtract 1, finish that parenthesis, and now divide, start a new parenthesis, 0.08 divided by 12, finish that parenthesis, and then hit enter. And it looks like I have $447,494. Let me get the exact amount. 447,494. So that's after they retire, they have almost $500,000 is how much they have to live on in retirement. Here's a person saving for college for their child. So they're putting in, well, they don't know how much they want to put in, but they do know that they want to have $80,000 in 14 years. So the 80,000, that's going to be A in our problem. 14 years, that's going to be our Y. APR, I've got that. And let's see here, deposit monthly. So we're going to have n equals 12. Let me go ahead and put the numbers in. Well, let me put the formula in first. And now I'll get my numbers in. So we still don't know what the PMT is going to be. I'll put a dot after it to remind myself I'm multiplying. Start my two parentheses, 1 plus, we're told that we can get 0.05, and we've got to divide that by 12. Now we've got 14 years, so we're going to have 12 times 14 minus 1, divide 0.05 divided by 12. And as before, I'm going to do the 12 times 14 separate. So 12 times 14, that's 168. So I'll replace that with 168. So, oh, I know what the A is actually. The A is 80,000. The idea is here, you'll get everything, you'll know everything in the next step except for the payment, and that's what you'll solve for. So I'm going to use my calculator to give me all the stuff that comes after the dot. So what is that stuff? I've got a double parenthesis, 1 plus 0.05 divided by 12, finish that parenthesis, raise that to the 168th power, minus 1, finish that parenthesis, divide, start a parenthesis, 0.05 divided by 12, finish that parenthesis, and hit enter. So it looks like $242.60. Now you want this number to be several places of accuracy. So let me go 5 places. 5983. We'll stick to that. 5983. So that equals 80,000. If I want to get the payment now, what I'll do is I'll divide by the 242.5983. And then I'll have my payment all by itself. So I'll let the calculator do that stuff that is on the left. So I have 80,000 divided by 242.52983. Enter. So it looks like 329.76. This is appropriate to round it to 2 decimal places when you get the final answer. In this problem here, what we need to do in order to have $100,000 per year forever, we need for $100,000 per year to equal 5% times the total balance. The reason is this: if you can live on 5% or less, then you'll be fine. So let me put in my numbers here. 0.05 times, I'm just going to call it by the capital letter T. So I'll divide both sides by 0.05 and see what my calculator gives me. It looks like $2 million. In addition, let me ask this: how much should you deposit to achieve that goal? So I want to get my $2 million. And in fact, I'm going to put a little thing in here. I'm going to deposit each month. So then my end is going to be 12. So let's see what we have then. I need $2 million to be in the account at the end of my 30 years of working. Now, the APR here is 5%. So we have 0.05 divided by 12, and that's raised to the 12 times 30 power. They worked for 30 years, 35 years old and retiring, starting at 35 and retiring at 65. Minus 1 and the parenthesis, start a new parenthesis, 0.05 divided by 12. And now, as before, I'm going to do all the stuff over here that's after PMT. So I'll start with a double parenthesis, 1 plus 0.05 divided by 12. Finish that parenthesis, raise it. Now 12 times 30 equals 360. Now minus 1, I'll finish my parenthesis, and then I'll divide, start a new parenthesis, 0.05 divided by 12, end my parenthesis, hit enter. It looks like 832.26. I caution, use as many decimal places as you can live with here, because if you use too few decimal places, it'll throw your answer off by a lot. So I'm going to divide by exactly that number, 832.25864. Same thing over here. And let me get my calculator for that. So 2403.10. 2403.10. That's how much you should be putting in every month. When you are planning for your retirement, chances are you're going to be looking at different stock portfolios that you might be purchasing. These are two formulas that we use, and it gives us a way of telling how well our investments have done. Let's look at the total return as this formula here. A is the amount that you have after it has accumulated value. P is, of course, the amount that you put in originally. So here was $80 per share, and we bought 100 shares of it. So they paid $8,000 originally for it. So when I put in my numbers here then, the A is 12,800, and I'm going to subtract 8,000, and I'm also going to divide by 8,000. You should recognize this as something we've done over and over and over again. Let me get out the calculator. And then multiply by 100%. 60. And then the annual return. So my A was 12,800 divided by the amount that I put in originally, 8,000. That will be raised to the 1 divided by, how many years did we do this for? 6 years. There we are. So 1/6 minus 1. 12,800 divided by 8,000. Enter. Now I've got to raise this to the 1/6 power. This is a bit strange, but here's how you do it. Let me bring my calculator up here. I've got to raise that to 1/6 power. So let me hit the y to the x button. So I'm going to hit the number 6, but I'm going to flip it upside down by hitting 1/x. There, if you look, if you can see this up here, I have 1.6 to the 1/6. It's got a weird parenthesis, but let's see what happens there. Equals, and then I'm going to minus 1. And it looks like 0.08148. And chances are they want it as a percentage, so I'll change it to 8.148% is the annual return.